Welcome to IBM Industry Assisted Lecture Series on building your own data preparation models using Data Prep Kit. This is session 3. I am Robin from PAL's Program Management Office. I will be moderating this session today. I would like to reiterate the basic instructions once again. For easier identification, please rename your Zoom display name as college short name - your name. Participants will stay muted and allowed to unmute only during the Q&A session. Chat box usage will be restricted. You can message the host or the co-host. We will enable it only on need basis. During the session, if you have questions to be asked to the speaker, please write it to askpalspmo@gmail.com. This mail will be monitored throughout the session. Ensure that write your name and college short name as well as along with the question. The other way to ask your question is use the raise hand option to interact with the speaker. Attendance link will be posted soon. Make sure to mark your attendance. Please close the browser right immediately after you mark your attendance. Participants are requested to register in Slido at the beginning of the session. Feedback link, recording, and presentation material will be shared by mail post the session. Now, I request Ms. Vijayalakshmi Shankar, co-chair, to give the opening remarks, and followed by Mr. Ravindran will introduce the speakers. Over to you, ma'am.
Good morning. It's my pleasure to welcome all of you for the third session of building LLM applications by IBM. I extend a warm welcome to all the participants, faculty, and students of all our partner institutions. We've had a great participation in the previous sessions, which covered theory and an illustration. And now it's with your own example that you're going to practice in this session. Very, very warm and thankful welcome to Sapta and Param from IBM for doing this session for us. We've had a record number of participants on these the first two sessions. So that shows how much of interest our students and faculty are having on these subjects. And I'm sure they will take it further, which fits into the objectives of IBM for doing this program as well. So warm welcome to both of you. And welcome to all my PALS colleagues, CNC, who's the chair of PALS, and Ravindran from Kerala Hub. Kerala is a new hub, and we have participation from Kerala. We also have participation from Andhra, Telangana, and Karnataka as well. So in spite of being Saturday, I think we're having a good number of participants. And it's nice to see how the theory illustration is now culminating into an example that our students will be able to try. So I'll hand it over to both of you to do this. Sorry, before that, I will hand it over to Ravindran to do a context setting and also introduce you to the audience. Thank you. Over to you, Mr. Ravindran.
Thank you. Good morning, everyone. I'm delighted to introduce our esteemed speakers for today. Today's session, Ms. Sapta Surendran and Mr. Parameswaran Selvam from IBM Research Labs, Bangalore. We are extremely fortunate to have them here, especially because they have been involved practically with the development and launch of the IBM Granite models. In the last few sessions, we have seen how important it is for preparing the data before we train the models. Because especially when we take material and content from the public domain, there could be so much of junk inside that, and we may have to filter it out, remove the duplicates. You have seen all these techniques and the tools available for doing this kind of data preparation. Now, all the knowledge that we have acquired over the last few sessions will be put to actual practical use today. And our experts, Sapta and Parmeshwaran, will be guiding us through a hands-on tutorial on building your own data preparation modules using data prep kit. So this session is designed to equip participants with the skills and knowledge needed to create a scalable and efficient data preparation modules. By the end of this tutorial, you will be able to contribute to open source projects as well, apart from enhancing your technical eminence. Ms. Sapta Surendran is a skilled research software engineer with a strong passion for designing and developing complex software systems. Currently at IBM Research, she specializes in data engineering for large language models, focusing on improving code generation capabilities. Her expertise includes meticulous data preparation and management, ensuring high quality code within the pipeline. Sapta has played a pivotal role in data preparation for IBM's Granite models. Parameshwaran Selvam is a senior research software engineer at IBM Research, specializing in efficient data processing for large language models. He is currently developing a scalable code data processing pipeline for IBM Granite models. With a strong background in software systems, he has also contributed to various open source projects. I'm confident that Sapta and Parameshwaran's insights and expertise will make this session both informative and engaging. So please join me in welcoming them into the session. Thank you so much.
Thank you.
Thank you, sir. I think we can get started, right?
Yeah.
Let me share my screen. Yeah, I hope everyone is able to see my screen.
Yes, we are able to see it, Mr. Par.
Yeah, thank you. So for today's agenda, we are going to look at this hands-on session, how to build a new data preparation module using our data prep kit. I think in our first session, we have looked at how to, basically we have kind of gone through what is the need for data preparation for LLM application and various methods or methodologies used across different data preparation modules. And in the last session, the session 2, Shivdeep talked about how to use the existing data preparation modules, how to kind of arrange the existing preparation modules such a manner that we can kind of address a specific use case, right? So now it's our turn to develop a new module based on our use case specific, then how to contribute to this open source project called Data Prep Kit. So with that, right. So for today's session, I'll be using this data prep kit and we will be kind of developing a new module. So I highly recommend everyone to kind of refer to this URL. And yeah, so I'll share you how to kind of prepare our development environment. Then we can, from there, we can start the development of our coding, right? Coding the new module, right? So go to this URL, data prep kit in github.com, IBM data prep kit. So you can find this repo called data prep kit, right? So here, so as a open source best practice, so it is a highly recommend that we basically fork this repo to our personal organization, the repo organization, right? So I recommend the participants, the students to kind of fork this repo. So if you do a fork, so you'll be like, you'll be asking, where do you want to kind of fork, right? So you can choose your organization. So here, since I've already forked, so it says that fork already exists, right? So since whoever is doing the first time, then you can select that specific organization and from there we can start. So yeah. Let me give a minute so that others can kind of do a fork. Then we can go to the next step. Yeah. Okay. Yeah. So once everyone has forked this particular repo, then you can find the repo URL like github.com/ your GitHub account ID followed by data prep kit. This is how we will find our forked repo. So basically, the reason why we fork the repo, right? So we don't want to pollute the base repo. So basically, whenever we make a code contribution, we tend to kind of uh, uh, push a branch. That branch will be staying, and it will be the maintainers responsibility to manage all this, delete the branches and kind of thing. So it's always the best practice to fork it and use it kind of thing. So that's the reason I'm just kind of giving that background here. Okay, so once you all forked it, right? So yeah, so let's take a look what is the directory structure of this data prep kit. Basically, some understanding of this uh, code structure will help us to do the contribution effectively, right? And also we can arrange our code module also specific to this existing data structure, or sorry, the folder structure, right? Yeah. So I'll just highlight what are all the directories which are very crucial for this particular framework or the toolkit, right? So the data processing lib, it is basically the core library provides all the abstractions or interfaces which can be used in our own code preparation module. So this is the processing library. So we will be using some of the APIs or interfaces which are defined in this data processing library, right? And I think in the last session, Shivdeep has kind of explored this particular directory where you can find the different pre-built or the other developers who have already contributed the different data preparation modules, right? So here, if you look at, there are three directories, code, language, and universal. So based on the nature of the data, the code preparation modules are grouped here. Say, for example, if our use case is to process code specific data, the programming code, right? Programming language specific codes. So those specific modules can be found in the code transforms code folder. So here we can see that there are different pre-built modules are available, right? So NLP specific modules, we can find it here in language folder. And there are modules which can be used across whether it is a code data or the language data, right? So such modules, right, can be found in universal, right? Say, for example, the exact deduplication module, it's not specific to the data as such. So that's the reason it's present in this particular folder, exact EDDU and FDDU, other filters here, right? So we will be like, so I want to give some idea about this new transformer. So basically, the noob transformer, it's like we can consider this transform as a kind of template, and we will be using this particular new transformer to build up our own module, right, today. So I will kind of go through it when in the next coming minutes kind of thing, right? So yeah. So this is the directory structure with respect to the existing transforms. Yeah. And the other folder I want to kind of highlight here is the KFP pipeline. For example, if we want to put our modules with respect to the Kubeflow pipeline or something, so we can, there is a set of scripts or recipes are available to build up the Kubeflow pipeline using the available transformers in this particular project. So that is also present here. So I'm not going to talk about this KFP today, but just I want to kind of highlight there is a provision to build up, use our modules in the KFP way of deploying it and using it kind of thing, right? Right. Yeah. So any questions with respect to this arrangement of the directory structure, please post it in the chat window, then Sapta can address here. Yeah. So, okay, let me start from a documentation folder. Yeah. Okay. So basically, so we know that I think in the first session and second session, we basically referenced the raw data and set of transforms and how that the transform data used in the model training kind of thing, right? So this is the complete, this is just an example of one such an example of that flow. We can build up this kind of flow using this data prep kit, right? So here, the representation of data is kind of standardized such a way that this data prep kit expects the input in the form of Parquet. For example, most of the transformers what we have in today, all of them are taking Parquet as an input and Parquet as an output file. So that is the arrangement of the data. For example, if we have a data, the data is in a different format. For example, it could be a PDF file or it could be some kind of a zip file, that kind of thing, right? So we have a transformer which can convert such for that file format into a Parquet file so that that can be used across our existing filters or the new filters. So that is so basically we want to standardize the input output format so that it will be common across all our code preparation modules, which are present in this particular module, right? So that if you look at here, we are taking raw data as an input. The minimum requirement for the module to process contents column, say for each sample in the table is a kind of either it could be a one language sample or it could be a code sample. So when I say code sample, it's like some kind of it's a code, it's a program file kind of thing, right? And we expect that one unique identifier, it's a document ID, and basically we as kind of explored in the last session. So we need some kind of meta information. For example, if someone asks, okay, where okay, there is a data set. What is the source of this data set? From where we have downloaded this data set, kind of. So if you want to kind of tackle such a questions when we process the data, so that's the reason we, along with the data, we have some kind of meta information like the URL from which repo we have downloaded, whether it is, for example, if it is a NLP data, we downloaded it from Wikipedia. So we can have a reference to that URL. Okay, this is the page in which we have downloaded this data, and this is how we are using it in our pipeline kind of thing or model training. So that's the reason we keep always the best practice to keep some meta information about the data, right? So that information is also kept as part of the data which we are interested in kind of thing, right? Okay, so and if you look at that, so we can once we build up different modules, we can arrange it in a such a way that based on our use case, for example, based on the need or based on the task, we can kind of place the code processing, code preparation modules in a manner so that it will be like transformed from one form to another form, and finally we can use that data to train the model. So that's explained it here. Yeah, I think then I want to show. Yeah. Yeah, in the last session, basically, Shivdeep talked about how to set up the environment to run the modules, right? So the same steps, but today since we are going to create new transforms, so I'm going to focus on this, adding a new module using this repository. So as I mentioned, we will be using this new transform as a template to build up our own module kind of thing, right? So I'll kind of take you through this thing. Before that, I just want to give some idea about how the code structure. Now we looked at the repo structure. We will look at the code structure, how the codes are arranged, what is the modularization followed in this particular project kind of thing, right? So that I will talk about now. If you look at as I mentioned previously, data processing library is our core module in this data prep kit. So that's the module basically provides all the interfaces like runtime abstraction, data access abstraction, and transform abstraction. All this and abstractions are provided by this data processing library, right? So if you look at under this library, there is a documentation folder. I think this is the first place we should kind of explore. So if you look at here, there is an overview here. Yeah. So if you come here, then you can find out how this what is a class hierarchy, right? Or how this, basically it's a kind of a UML diagram kind of thing, entity relationship between the different classes which are present in this particular framework, right? So as I mentioned, there are three core components or core classes in this particular library. One is data access abstraction, basically the data access layer, which basically abstracts out the different storage classes we can use through this particular project, right? And the runtime. So what I mean by runtime here, it's like whether it running on the local machine or we are running it on the cluster, what type of cluster, whether it is a Ray specific middleware or Spark specific middleware. Okay, so whether it is it's from a transform the code module perspective, it doesn't matter whether we are running it on Ray or Spark, because those all this complexity of that such things are abstracted out by this particular Ray transform runtime configuration, right? Yeah. See, for example, if a student or anyone wants to kind of add a support for a different runtime altogether, so in that case, they have to kind of extend this particular runtime configuration. For example, today our data prep kit supports local file system, basically the cloud object storage also it's supported by this particular data prep kit today. For example, if student wants to support in-memory database kind of thing, right, Redis kind of thing. So in that case, how do they can add that support by extending this particular data access class, right? Okay. So then the third component, which is the third abstraction, which is transform, abstractable transformer. Basically, that's it provides that abstraction such a way that whether it is a code module or language module, it doesn't matter. All that interfaces are unified, so that from a new code module preparation perspective, it is same across it doesn't differ from the nature of the data. So that is the third abstraction layer, what we have from this particular class or layer, right? So this is the any questions with respect to this class hierarchy, just post it here. We can clarify this. But overall, we will be like touching this kind of, these are all the different classes. We are going to extend these classes and use it in our data preparation module. Okay. Yeah. Okay. Yeah. So I think I covered some basic theory part with respect to how this repo organized, code organized within this particular module. So I hope everyone has kind of forked this repo so that we can use it in our preparation, right? Okay. So what is the use case we are going to use today to develop a new code module? So I've just picked up one use case from here. It's basically there are issues which are kind of marked as a good first issue kind of thing. So anyone can kind of start from this particular issues. So I've picked up this particular use case where build a transform to remove dead code from code files, right? Yeah. So what is the use case here? So basically, you know what is dead code, right? The code which is basically not reachable, or the code or a function which is not used in any of our logic kind of thing. So such codes we want to kind of remove, right? So why do we want to remove, or why do we want to kind of extract out such a code, right? That is again case to case basis. For example, in a pre-training data set kind of thing, we don't want the model to learn about such a bad pattern kind of thing, right? If you consider this dead code, if a model is going to generate generate a code with some kind of the code which is not used in any of the flow, then it is not appearing factor kind of thing, right? Or for example, in a fine tuning, in a different use case perspective, where we want the model to kind of, say for example, the use case is something like the LLM application is something like we are applying this, let's say, assume that the Granite model to find out a bug in the code contribution, right? So if you we want to kind of, one of the cases, the model should kind of highlight, okay, if there are any code which are not used in any of the flow kind of thing. So in such a cases, we want to have set of examples of dead code, and so that we use those examples to teach the model, okay, if you find this kind of pattern, so identify those pattern and mark that as a dead code kind of thing, right? So it's not used, so you can remove kind of such a recommendation can be provided by the model. So we want, based on the use case, whether we want to remove it or we want to kind of keep that as a separate data set as such to train the model for, that is based on the use case kind of thing, right? So so we will be using this requirement for this basically to build up the module, right? So how are we going to do that, right? So there are tools which are available. Again, that is based on the programming language, the code, right? So there is a tool called Vultr for a Python, and there are different tools are available. And also to build up this particular module, we can use the model as a basically kind of as a function in this particular module. But for now, since we are going to do it through in this session, so we will restrict to ourselves one programming language, Python. So and we will use this module called Vultr, right? So so basically, let me show how this tool can be used here. So so once you have this tool called once you install this tool in your system, you can just provide any programming file and call vultr myscript.py. Then it will tell whether it is, if there is any code which is found to be like a not reachable code or not used function, then that will be kind of flagged. Let me show an example of that. Okay, I've installed Vultr here. Okay. 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 See, if you look at this, there is a program file called deadcodeannotator.py. So that's the program we have. And I'm just asked the Vultr to identify if there are any dead code. And it has come back saying that, okay, there is a code which is after the return, there is a print. And also there is a function which is not used at all in the program. So it's basically, it is identifying the code as dead code in the context of the specific file, right? This function could be used in different function, different file altogether. But as long as the first the 100% confident, right? So basically, with respect to this marking, so this is perfectly correct, right? So if you look at the program here, here at line number 17, I have put a print statement just after the return. Since we are returning from this line number 16 itself, never during the execution of the program, this statement 17 will not be executed, sorry. So right, so even in the IDE, the sense I'm using this Visual Studio Code IDE here, IDE itself kind of, you're giving some color coding here to basically to highlight that, okay, this is not reachable code kind of thing, right? So this is one program, and we are able to run it through command line. Assume that we have a volume of data, so we want to kind of process some 100 files or 1,000 files, program files, identify all the dead codes present in the input program, those 1,000 files kind of thing, right? So how do we do that? So we want to kind of scale it. So for that, that is a place where we want to use this data prep kit to kind of scale this particular use case kind of thing, right? So we can start with that one. Yeah. Yeah. So let's start from cloning the repo first. So to start the coding, we need this code in our local file system. So what I'm going to do, I'm just going to clone the repo. So for that, I'm going to, since I've forked the repo, I'm going to use my fork to clone it. So I'm taking the copy of this. So you can use the HTTPS to take the copy of this particular URL. Come here, you just say git clone, right? Copy this URL and put this here. So I'm just, so basically I'm using a terminal here. You can use whatever the terminal you have it in your system. It could be a command prompt or it could be any other terminal, right? So I'm just saying that git clone, this is the URL. So it is cloning the repo now. So as you see, right, I'm using my repo here. So basically the repo from my organization, the personal organization. Yeah. So it's cloned successfully. So if you look at here, data prep kit is now downloaded, right? Yes. Okay. So we can get into this folder now. Yes. So if you look at the same directory structure, we can find it here. So we will be using the same directory structure here to kind of build up our module. So to add a new module, we just need to go to this particular directory, transforms. Okay. Since the nature of the data we are going to process is programming files. So we are going to place our module within this code folder, code directory, right? Yes. So in code directory, we have all this existing pre-built modules. So we will name our module as dead code marker or whatever the naming convention we want to follow. We can use it. For now, I'm using name called dead code, say marker. Okay. Okay. So I just change to the directory. Now, if you look at that, I'm into transforms code, dead code marker. I don't have any files. As I mentioned, I'll be using the new transform module as a template for building this particular module, right? So I'm going to copy that for specific file. So that specific transform present within the universal folder. So for that, we have to go to level before and to universal and copy all the files. Since the folder has other directories, we should use -r option here. Copy -r. Okay. So I copied the files here. If you look at, I've got all the files. The reason why we are using the Noob as a template here, it comes with all the pre-built recipes also. For example, this project provides very good build system using Makefile. If you look at here, you see we don't need to run specific commands in command line to compile the program or run the program. So there are so many make targets here. So you look at build this project, build the module, convert that module as a Docker image, and publish this module to some Docker registry, right? And test this module kind of thing. So that kind of automation provides this particular project, right? So we are basically, if you start from the scratch, then we have to define all this build systems. So that's the reason I'm just copied those files from Noob to here, so that we will be like getting all these benefits, right? Okay, so now, yes. So as okay, now, so we have the setup now, the base code we have now, base directories, base recipes we have now. If you look at that, here there are 3 folders, Python, Ray, Spark. So basically, if you want to run it on your local system, we can use the Python. If you want to run it on a local system, but a Ray cluster, way of doing it, like multiprocessing, parallelizing the execution. So we can use either Ray or Spark. So let's start from Python first, then we'll look at the Ray and Spark later kind of thing, right? Yeah. So sorry. Okay. Okay. Yeah. So now I'm getting into folder called Python. So if you look at here, there is a project, PyProject TOML file, which basically defines the dependencies and structure of this particular module, right? So we will be like editing this file, and there are program files we want to customize it, right? So yeah, okay. So so basically, to make this development little faster, what I've done is, before the session itself, I've developed a small program, uploaded that into my repo. So you all can download it and use it so that we can all quickly build this particular application, right? So let me show you what I've done. See, if you go to go to this URL, you can download the files. So github.com param s data prep kit. Under that, there is a branch called msrit demo, right? So here, if you come here in transforms code, okay, date code Python. Okay, so what I've done is I've kept two sample Parquet files, basically to process, right, to test our program or module. So there is a two Parquet files I've kept it. Then there is a code, right, date code annotator. So this annotator file basically uses vulture to annotate that given the input file, whether is there any dead code or not kind of thing, right? So that's code. Basically, it's a kind of a skeleton code, but we will be using this code to parallelizing it using our data prep kit, right? So that's what we are going to do. So you can download this file. Say, for example, you can download the raw file, and I'll show you how to where to keep this file in our local file system. Just do a download. Also the test samples, sample1 Parquet, sample2 Parquet. So those two files, three files, we have to kind of have it in our, should be in our local file system. So whatever, you can see it here. Sorry. Yeah. So I've just downloaded the files, dead code annotator, sample1 Parquet, sample2 Parquet. So what we have to do now, okay. Copy the files from that specific location to SRC, the program file, right? Copy the program file from that. So I'm going to copy. To here. So I have that file. So I can use it in my a transformer module or the code preparation module, this particular skeleton code or whatever, right? So, okay. So for code editing, you can use any editor. Basically in our session, I'll be using this Visual Studio Code for kind of a quick edit kind of thing, right? Right. Yeah. See, I'm getting into that same folder, data prep kit, transforms, dead code. This is a folder this is the directory we created. Under that, there is a Python folder. There is a SRC folder, right? There, we will be like editing this noob transform.py file, right? Okay. So this is the skeleton code. So during our the first part of the session, right? I just referenced some classes and its hierarchy, right? As you can see here, there is a base class which is called abstract table transform. Basically, in our code module, the custom code module, we are extending that class and implementing it, right? So basically it is like overriding that particular the functions which are defined in the base class, the init, the transform or transform method. So these are the methods we are basically re-implementing it in this particular code preparation module. So we will change this name of this one. Before that, I will just talk about other classes and stuff. Yeah. So in other class, we are extending here is the transform configuration. The transform configuration is again the runtime configuration we are talking. We referenced in the class hierarchy, right? The same one. We are extending that particular base class and doing whatever the customization we want to do in this particular module. So that is also we are doing it here. Yeah. So yeah. So let me start from here in the new transform configuration. Right. Yeah. So basically what we have to do, we want to identify the dead code here, right? Is there any specific configurations we want to handle it in this particular code module? Yes. So there is if you look at here, we want to see, for example, we may need to tune the dead code identification module such a way that, okay, if code is identified code, the minimum confidence level is like below 50 or above 50 should be used for our code preparation kind of thing. That kind of tunables, if we need, such tunables or command line options should be defined in this particular configuration, right? So yeah. So for that, we'll call this particular, so let's start to edit this particular file for our use case, right? So what is the name of this particular module? So dead code marker. Okay, so I'll just, instead of it says short name, so I'm giving some bigger name. So I'll just give some shorter form, DC marker kind of thing, right? And so basically, in addition to that existing parameters, so I need one custom parameter, which is the minimum confidence score kind of thing, right? So we can just call that as a, say, min conf key, right? So that is a variable we want to use it in the configuration. So that is called min confidence score, right? And that specific when it is basically it is when it's shown in the command line. I'll show how it will be appear in the command line, but when it showed in the command line, how it should be how it should appear, right? So that is also we can define it here. Say min conf CLI parent, right? Right. Min conf. Okay. So basically what we have done, we have defined a new command line option. The name of the command line option will be, say, DC underscore marker min confidence score. Okay. So we just define the variables. So how we just go here in this transform configuration class. So can we, instead of saying this is a new transform configuration, since we are building a new module and the name of the module can be like a dead code. So we just rename this particular class dead code transform configuration. So dead code transform configuration, extending the transform configuration here. Okay. The transform class we are going to use here is not noob transform. It's a dead code transform. Dead code transform. Okay. So this is a kind of a constructor which will be invoked and passing on this particular values to the base class. So that's whatever the name we want to use it in our transform class. So we just given this. Okay. Okay, that's fine. In the add input params. Okay. So since our dead code transform class, the dead code transform module is having one additional parameter we want to kind of we want to parse and use it in our module. So for that, what I'm doing here, so I'll take a copy of this one just to avoid some typing to make it faster. Yes. Okay, so I'm adding a new argument. So the argument is min conf CLI param. So this is the one, basically we defined it in here. So this is the variable we defined it. So the same variable, I'm referencing it here. Okay, that variable type is not a string, it is an integer type. Okay, make it integer. And since it's integer, what is the default value? We want to keep it, say, 100. Okay, then whether this variable is required or not. Okay, whether the user, whenever someone uses our module, right, do we want to force them to specify this particular command line option or not? That can be determined through this particular attribute called required equal to either true or false. So I make it false now, true now, so that we can I'll show you how it will be appear. Okay. So if the user provides some incorrect value, or if the user is not inputting this value, what will be the help message we want to provide? Okay. I'll say that, okay. Uh, um, the confidence, okay, let code confidence score value is must. Value must be in range 0 to 100. So this is a help message when the user, whoever is going to use our module in their pipeline, right? If the user inputting some incorrect value or not providing this value, this particular help message will be appearing. Okay. Okay. So this is fine. So we define the new command line option now. So now what we are saying, our command line is expected a value in the range of 0 to 100. Okay. What if the user inputs some value which is less than 0, which is in minus, or if it is greater than 100? So do we want to kind of capture that and kind of highlight that one? Yes. Right. So for that, we can again, to avoid some coding, and just copying this statements and keeping it here. Yeah. So what is the key? The min conf. Okay. Okay. Right. So if this particular command line option present or input by the user, okay, let's validate that value. If it is less than 0 or greater than 100. Okay, what if it should be 0 to 100? If it is not in that boundary, then what we want to say, we want to give the same message, or we can give some other message also. Incorrect value for confidence. So it must be 0 to 100. So that is a different message we want to kind of. Okay. So yeah. So now let's not let's do the other cleanup later. But for now, it's like we are just adding up our own logic into that existing template. Let's okay. So now the command line option of so basically now we have make sure that our new module having the new command line options, and user can input the values kind of thing, right? Okay. Okay. Now, so we have extended the dead code transform configuration. Now it's the time to kind of update the core logic, right? So the core logic comes here, right? So what we are doing, we are basically extending the abstract table transform. That is a core function, basically invokes or basically it takes the Parquet files as an input and giving it to the child classes. So and asking the child classes to process the data and get return back the processed data to the base class. So all this abstraction of reading the file from the local file system or a cost of cloud object storage, all this are abstracted out to this code processing module. So we just need to so from our module perspective, we are getting input as table. So we are not kind of concerned about, the module is not concerned about whether it is coming from local file system or external storage. It doesn't matter. All these are abstracted out because of this input, which is only type of a table, right? So we call this class as dead code. Sorry, dead code transform. Okay. Now there is a class called dead code transform. Okay. What it is doing? Okay. So now, since we have kind of introduced a new command line option, we want to have that command line option in our logic, so that that can be used in our processing, right? So all the command line option pass to this particular object through this constructor. The type of that variable or the type is dictionary, and the variable name is config, right? So in that config, we can find that particular input argument. Okay, self dot, say we can name it some small name, min conf. Okay, config dot get. What is the key of our min conf key? Okay, so min conf key, min conf key is the name of the attribute in that particular config. Okay, so do you want to, if user not providing this value, we make it required equal to false. So that means user is letting the module to use the default value. In that case, what is the default value? Say 100. Okay, so we are saying that, okay, 100 is the minimum. Okay. So now we kind of define a new class and define the constructor, how we want to kind of handle the input argument. Now, okay, now with the core function, the transform function in our code module, the transform function is the kind of heart of the function kind of thing, right? This is a place where we are getting the input data, and we are basically modifying the data and returning the data so that it will be stored back into the storage. Okay, so we are not using the existing logic here. Okay, so I just commented that portion now. Okay, let me check how much time. Okay, I think we have sufficient time now. Okay, okay, so now oh, so we let me talk about this first before using that. So dead code annotator is this is a function. Basically, I said that, okay, I just prepared it before the session so that it will be easy for us to kind of just go a little faster. That's the reason, right? So I just showed how to use vulture in command line here, right? So I just showed, okay, sorry. Somewhere here, right? Okay. Okay, so I just showed how to use vulture in the command line. So now we are going to use the same module, but through this program, right? And the programmatic interface in which we are basically accessing, right? So vulture here, I'm not using the program API. I'm not using the API. Again, we are basically sub-processing it and running the exact command only, right? So I'm invoking the vulture and passing in the sample and getting the result. Okay. The way I'm kind of identifying whether that particular sample is having a dead code or not by checking the std output, right? So let me show. Okay. Here, vulture, say new local.py. So when there is no dead code, when there is no dead code, vulture will say simply return back. There is no std out, right? If there is a dead code present in that particular input sample, then it will print those information, right? So okay, vulture has found these are all the dead codes in this particular input sample, right? So I'm basically making use of this particular information in this logic, right? If std out is not null, right? That means there is some information provided by written by vulture. So I'm basically I'm using that as a signal to say that, okay, this guy and this particular sample is having a dead code. If the STD output is null value, then I'm saying that that particular sample doesn't have any dead code. So I'm just saying I'm capturing this information as Boolean, true or false, right? So that's the logic of this particular function, right? So if you look at this, the dead code data filter takes data frame, pandas data frame as a input, and iterating through all the samples present in that particular data frame, right? So it expects in that data frame, it expects two columns. One is file name, other column is contents, right? So so this is the mandatory attributes should be mandatory attributes are expected by this particular module, right? If you remember, during the overview, I just mentioned that the raw table is expected to have certain attributes with respect to the code module, or sorry, with respect to the data preparation modules. Like that, this particular data preparation module expecting that the input table or input data must have this file name and contents column, right? So if these two columns are present, then this program or this particular program will run successfully. Otherwise, it will say that, okay, this column is not present. It will not be able to process the incoming data, right? So we will be using this particular method in our logic. Okay. Okay, noob transform. Oh, okay. Since I've copied all the files from Noob, so the same naming file names are followed here. But when you make a actual transform or actual code preparation module, you can modify this file names. For now, I'm just keeping the file names as it is here. Okay. So now I want to use this logic dead code annotator. So I'm just saying that from dead code annotator. Okay, import. What is the function I want to import? This function, dead code filter. Okay, so I'm importing that particular method. Okay, so I basically imported that particular method now. So now, what have to do? In our data preparation module, we received the table as an input argument. The argument name is table. So we want to process the table, the complete table, through this module. Okay, so for that, what we have to do? Okay, let me name it later. This variable, the variable later. So say let it go filter. Okay. Now, as per dead code filter, the input argument type is pandas data frame, right? So it's expecting pandas data frame as a input, but our transform return the base class giving the input in the form of pi-error table. So now we have to convert that table. So I'm just saying table dot to underscore pandas. Okay. So I'm just converting that. Okay. So, and it returning back again a data frame. So I'm just storing that data frame in a variable called say data frame. Okay. Now we have a so we have taken the input table, converted it as a data frame, passed to this dead code filter. Now that that particular method processes the complete table, the complete data frame, and return back with the modified data frame. Okay. Now we want to, again, since our framework or the data prep kit follows one type, which is the table. So again, so when we return this particular modified value back to the base class, we have to ensure that the same type is followed. For that, what we have to do is table equal to, okay. So the pi-arrow provides a method to convert from one format to another. So I'm just using that table dot, sorry, create table dot from pandas. So I'm here converting table to pandas, and I'm reversing it, right? from pandas, I'm creating a table. Okay, so now it is the same table is passed back to this the base class or the invoking method, right? Okay, so now this is the implementation of our new module. Okay, so I want to highlight one more point here. So as part of this our transform module execution, we may need to capture certain meta information. For example, how much time it takes to process the data, or how many samples it has found dead code, not finding a dead code. That kind of stats we may need to capture in our output, so that it will be easy for us to kind of do some kind of analysis, right? For that, we can use this metadata. So along with the modified data, we are also sending out metadata. Okay, so if you are, for example, by parsing through this data frame, we can say that, okay, this is the count of samples with dead code. This is the count of samples without dead code, kind of thing. So that is our valid samples or kind of thing, right? So that information captured in the metadata. So that can be returned from this one. Okay. So now we have kind of structured our, implemented our code module now, right? Now we can, it's time to kind of use it, right? Before doing that, I'll show you, sorry. I'll show you the input, the test files, test Parquet files, how to use it kind of thing, right? So I've kept this test files, sample 1, sample 2 here. So I'll just copy those files into our test folder, test data folder, so that will be easy for me to kind of manage it. Okay, so what I have to do, I have to go to test data input. Okay, I'm not going to use this existing test data. I'm going to copy my own test data. Okay, so which is present here, which is present in this folder. Okay, samples. So I have 2 samples now. Okay, we can use some command line tool called Parquet. Parquet tools is a command line tool to explore, basically to read this the contents of this Parquet file. So if you have not, so basically I'm not sure whether you have installed in the last session or not. If you have not installed this particular tool, you can do this through this pip install Parquet tools. So if you do that, then you'll be getting this tool onto your local system. So once you get this tool, what you can do, Parquet tools show the contents, right? So let me take this particular file as a one such example. Okay, yeah. So it has, these are the different values. So it has a contents column, what is the language and file name. So I think it is not easily readable. So I'll show this in the here, right? So I just prepared one notebook. I'm using some API or Python classes to kind of read this particular Parquet file. So if you look at the same Parquet file, I'm reading it here. As I showed here in this window, it has 3 columns. So same thing, but I'm using a different interface in which, so that it easily to readable kind of thing. So there is a contents column, there is a language column, there is a file name column. So we are, as I mentioned, for our own, for our code preparation module, whatever we have developed, the file name column, contents columns are mandatory. Those 2 columns are present in our input file. So our program will run successfully without any problem. So that's, we have to ensure this. Okay. Now, okay. Right. Now it's done, right? Okay. Now it's ready for, now we are ready for running the sample. Okay. So we completed the development. Let's test it out, whether that program, whatever we have developed now, whether it is working or not as expected, right? So what I have to do? Okay. Okay. So before that, I want to do one more change. For that, I want to show this pipe project terminals. I referred to this one before, but I didn't complete this one. Let me show this. Okay. So this particular py project TOML file defines our project or the module's attributes, right? So it name of the module is dpk noob transform Python. So we just name it as a dpk detcode transform Python, and we can give whatever the version we want. And what is the minimum required Python version to run our module, which is 3.10 kind of thing. What is the description of our module? See, for example, the reason why we have all this attribute is, see, if you are developing this module and if you want to make it available for other developers, the community, open community to consume it, your module, right? For that, you will be pushing this module to some centralized repository. It could be PyPy or any other place, right? So in that case, you should have a proper structure so that others can kind of easily understand, okay, this is the module and this is the purpose of this module kind of thing. So all this needs to be kind of well defined when you do all code contribution to open community, right? So for that, I'll just give this is a good practice to have this description. So detcode marker Python transform. Okay. And what is the license? There are readmes. So who's the authors? Since we are doing that, then we can update this authors. And okay. Now, if you remember, we are actually in our project, in our code module, we are using two additional modules, which has basically we have introduced two dependencies. One is pandas, other one is vulture, right? So those two external libraries should be installed as part of our module. So we have to define those. Okay. Now I'm defining it here. So what is the first one? The pandas. Okay. The next one is vulture. So these two modules are required for running our module successfully. Otherwise, it will break saying that, okay, this module, so and so module is not present when we try to run it. Okay. So now we are just save this file. Okay. Yeah. Okay, I just saved it. Now, since I mentioned, right, this project has providing very good build system, all the recipes to kind of easily compile and run it. So I'm going to make use of that particular recipes here. Say make venv. So basically, what I'm doing here is creating a virtual environment, Python virtual environment specific to this project. So that will basically take care of installing the required dependencies and compiling this particular sample files and putting it as a package kind of thing, right? Python package. So I'm doing make venv. See, as you can see here, it's taking up data prep kit as a base. So that is also done. So, okay. So we name this project, our package as dpk detcode transform. If you remember, we have done this, right? dpk detcode transform Python. The same module is prepared here. So by this particular. Otherwise, for example, if you don't have this particular make targets, right? Then we have to run this steps one by one manually. So that will be a time consuming. So this project provides all these recipes to build this particular project quickly, right? So we just need to focus only on the business logic or the module logic only here. Okay. Now, yes. Yeah. So now we have created the environment. So now we basically we should switch to this environment so that we can run using that environment, right? So for that, what we have to do, see, as you can see here, there is a new directory called venv. It is created this particular stuff. So we have to activate that particular environment now. So what I have to do, source venv bin activate. So what happened? So basically, it switched the Python environment from my base Python environment to specific to this module environment. So if you can remember, if you can see this, the command line, the command prompt, previously it was called parcel one so and so. Now it is called there is an additional portion, which is called Python environment, which is based, the name of the Python environment is venv. Okay, let me clear this. Okay, now we are within this one. Now let's try to run it. See, okay, cd to src. Okay, now we have updated. Okay, one thing. So we have updated this particular noob transform py file. Okay, we will be able to run it now. Only thing is, the way we want to run it, there is a this particular class should be instantiated, and accordingly the parameters should be passed to this particular class. So those logics are present in this noob transform.python file, right? So that we have to update this particular function to basically to invoke our module in command line, right? To run it locally also, right? So what is the name of our transform configuration? If you remember, we just named this as dead code transform configuration. We copy that in the noob transform Python file. We just say, instead of noob Python transform configuration, we say dead code. Sorry. Okay, this is the Python transform launcher, dead code transform configuration one. We have to use it here. Okay. Now here it is called noob transform. Okay, sorry, I think I just modified it, right? Correct. Python transform configuration. Here it is called. Okay. The transform configuration is passed as a parameter here. I confused here. The transform configuration is passed as a noob transform configuration. Here we just need to replace it. Okay. So that's how it is configured. Okay. So here you can see the Python transform launcher instantiating noob Python transform configuration, which is extending the Python transform runtime configuration, right? So inside that, what is the transform configuration we want to do? A dead code transform configuration. So instead of confusing dead code and noob, so we will rename this also dead code. Dead code Python transform configuration. So here also we say dead code Python transform configuration. So this dead code transform configuration is coming from a different file. So that particular class needs to be imported here. So here, if you look at this, then the name of the file is noob transform. In that, we want to import this noob transform configuration. For that, instead of noob, we are going to say dead code transform configuration. Okay. Now the launcher also is ready. So what is the step one is we define our module. Now we want to launch this particular module on our local file local system through Python runtime. So for that we have defined a Python launcher. So Python transform launcher, and accordingly we kind of instantiated the configuration, right? All right. Then it's ready for running this. Okay. Now we'll say Python transform noob transform Python. So don't confuse with the naming. So we just rename this all this classes, but we did not rename the file names. Okay. So I'm just running it Python and noob transform Python. So as you remember, we define a new command line argument, which is a minimum confidence score, and we mark that particular option as required. So that's the reason it says the following arguments are required. Okay. So if, for example, if you make it as, sorry, here, if you make it, where is that? Yeah. If you make it as false, so it is able to run it, but it needs one more argument. So it says there is no input output to process. Okay. There is no input output to process. So we will use the default value, the minimum confidence score of 100. We'll use it, but it needs input output configuration. So for that, we will specify those configuration. So since we are running it on local system, we want to use the local file system specific. All our samples are present in the data, test data are present in our local file system. So we want to point that specific location in this configuration. Data data underscore. So this option, data underscore local config, we have to use local config. Okay, so basically it expects JSON as a input. So which should have two attributes. One is input folder, other one is output folder. So we will be pausing that. So input underscore folder. Okay, so my data is, one second, my data is present in test data input, right? Okay, so here we have this data. So let's do, yeah, we have that data, right? So we have to specify that location. Okay, now just copy this. Okay. Okay. So, okay, this is the input folder where it should write the output. So we can define that folder location. So we can just name this file as output. Okay, and let's see how it is doing. See, it has identified there are two files are present in this folder. Okay, source profile, max file sensor. Okay, see, look at this. It is able to process the file1, file2. So it completed two files processing. Okay, good, right? So our module ran successfully, but we will see whether that it ran successfully, but whether it achieved the expected result or not by looking at the output folder only, we can confirm. Let's see. So I'll use this uh, the notebook to kind of validate that. So the file is present in this location, test data output folder, right? So, okay, I'll just copy this file, copy the path, go here, I just paste it here. Now I'll run it. I read the file. Now, see, look at this. It produced a new column named with as dead code, right? For this particular sample, since we are processing only the Python language specific samples, so it all marked as false, right? For this Python sample, it has found some dead code, so it marked as true. So that means our module achieved the expected result. So it's able to run it successfully, right? Okay, so this is well and good. So our module, we have written a new module which basically process the data and produce some output, doing some cleanup with respect to our task. Now I want to show one more thing which I talked about, the metadata. Okay, so when we ran this particular module, it produced as part of the output, it is produced the metadata.json file also. If you look at the timestamp, if you look at our time, so it's since I ran it at the same time, so it produced the start time, end time, what is the job name, DC marker, what is the category, it's a pre-processing category, and say output stats, how many files the input folder has, two files, what is the source size of the files. All this are some kind of meta information. From the data processing perspective, this meta information is basically help us to kind of estimate, okay, how long it will take the job to process. That kind of information is helpful for our execution time, our estimation capacity planning time kind of thing. So for that purpose only, we have all this meta information and also cross verify whether it is processed the exact files or not kind of thing. So see, if you look at this, the minimum confidence score what we have provided. So since we have not put any command line option value, so the default value is assigned to this one. That is also we can verify, right? Yeah. I think yeah, covered the complete flow. If you have any questions with respect to any of the steps or any of the modules or methods, please post your questions. I'll try to answer those. Yeah. I think, yeah, I'm done.
Yes, participants, you can post your questions. or you can raise your hand. I will unmute you. Okay, Sriram. 1 second.
I see one question in a chat window, Akshaya. So
Okay.
why should we use Vulture here, right?
Yeah.
Vulture, yeah. So Vulture is a basically a tool. We are using it now, using it in our code processing module. We can use any module which to detect the dead code, or we can write our own logic also. It does we don't need to strictly use the Vulture tool here. We can use any tool to detect the dead code. It could be even LLM can be used to detect the dead code, but we are basically using it in our logic just to showcase the usage of our code preparation module. Yeah.
Okay, one more question, sir. How to fine-tune existing LLM using data prep tool from Krishna?
Sorry.
How to fine-tune existing LLM using data prep tool? That is a question from Krishna.
Okay. So basically, existing LLMs fine tuning with respect to, right? So basically, so the data preparation kit is to prepare the data for either pre-training the model or fine tuning the model based on the use case, right? So for example, your task is to kind of fine tune and pre-trained model. So you need basically you have a certain set of data to do the fine tuning, right? So if you want to process that particular data, right? Processing in the sense you want to do some cleanup, validate some the structure of the data in a scaled manner. You can use this data preparation kit to kind of process the data, the fine tuning data, and then use that process data to fine tune your model. So it's like a step of fine tuning task. But for fine tuning, you'll be using this data, right? That data needs to be processed through this particular, so it can be processed through this particular data prep kit. Okay, I want to share one more point here. Okay. See here, since we have a good number of students here, if they want really interested to contribute this particular, sorry, here in the issues, if they are really interested to contribute, develop new modules using this data prep kit, so they can start from this particular first issue. They can take any specific issue, or it's basically those are all not issues as such. Those are all kind of enhancements to this data prep kit. So you can write a new module, or you can add some new capability to this core data prep kit itself, right? So you can use this particular place as a starting point. Yeah. Can we provide, there is a question from Monisha. Can we provide with recorded videos of live session?
Yes, we will share after the session. We will share, Monisha. any questions quickly? So before getting into the Slido quiz, we'll expect one or two quick questions from the audience. Ma'am, are you ready, ma'am?
Yeah.
Okay. So now it's we are moving into the interesting session, the Slido quiz. I think that quiz link is posted in YouTube as well as Zoom. So please, please attend the quiz. Now I request Ms. Sujata to take over the Slido session.
Okay. Thank you, Mr. Param. I think it was a very detailed hands-on session today. So participants, as we have reiterated this multiple times, it will be better for the speaker and as well as you, if you ask questions and exchange thoughts. All of these sessions are not typically going to follow your, classroom style of teaching wherein, we just have one person speak and all of us listen. So here we are trying to encourage in PALs, as much as interaction with the speakers is possible. So it is a good practice. Again, I'm reiterating, even if it is not done in this session, but for the future sessions, please keep in mind that no question is a big question or a small question. Whatever comes in your mind, kindly get it raised because that might trigger some more questions that will follow. So now I will, without any delay, I'm going to share my screen for the quiz. Just give me a second. The quiz link has already been shared. Now, when you click on the link, it will take you to your browser. So stay on the browser. It will ask you for your name and your email ID. I hope all of you have already done the due necessary things. And good practice again here is to append the name with a college short name. It will help us, identify you through your college. I'm just going to give a minute. 520 are already there, so which is a good number.
So people are saying still the link is not working, but many people have already joined. So please check your internet connection and see.
No, there is the quiz is not open yet. Hold on. And one thing that I would like to tell is the Zoom screen is not going to be responsive. You have to go to your browser, whichever browser you're using, Firefox, Safari, Google, Chrome, Internet Explorer, whatever you're using, please use that. It is not that, it will, the Zoom screen will respond. I'll be starting the quiz now. It's a timed quiz. Those of you who have attended the last two sessions would have already seen it. So I'm assuming that you're all not new to it. So here comes the first question. I'm clicking on the first question. The first question will come to you on your screen now. It's a 20-second. The time has already started. I hope now you're able to see the question. I repeat again, please stay on your browser and click on the browser screen to answer the question. Okay, 80% of you have chosen option B, and that is the right answer. Wonderful. So moving on, here I see that only 353 out of the 600 odd people have responded. Again, you need to be quick. The questions will come from the time the questions come, 20 seconds. So 20 seconds is a good time. Be fast. And all these were covered in the session today. Okay, and the right answer is Python. 93% of you have got it right. So the other 4%, who have opted for others, kindly, go through the recording once again. Option 3. Yeah. So option D is the right answer. Moving on to the fourth question. The right answer is option A. 80% of you have got it right. Question 5 on the screen for you. Not bad. 609 out of 776 have answered. And transform is the right answer. Good. Question 6. Some mixed response here. And the right answer is option A. 55% of you have got it right. Question 7. Okay, good. 79 have got it right. It's both A and B. The last question. Yes is the right answer. If you can come back to the Zoom screen now, we find that Rushi, Aditya, Ritika, Puvita, and Alan Moses. All of them have got 8 on 8. I remember Puvita got the top score yesterday also, if I recollect it right. So wonderful, Puvita. Congratulations. I see that, you're completely hooked on to the session. Now, why Rushi is at the top compared to the others is because she's managed to answer these questions in 0.22 seconds, basically. So wonderful. Congratulations to everybody who has taken part, and best wishes to all. Thank you.
Thank you, ma'am. Thank you,
stopping the
Mr. Jata.
quiz. Yeah.
So,
Do we have any
participants-
more questions to the speakers? We have Ms. Sapta and also Mr. Param from IBM. Saturday, they have spared their Saturday. So it's nice of us if we can ask us few more questions and get it clarified. There are many of you who are working on this particular technology. Any questions? The chat box is enabled, I suppose. I don't think I have disabled the chat box.
No, it is enabled only.
Yeah.
If you want to ask, you can raise your hand. We'll unmute also.
At least some response. Yeah, somebody has raised their hand. Who is that?
Yeah. Revant Kumar. Revant Kumar, you can unmute and speak.
Any faculty in the session who have questions for the speakers?
Yeah, correct. You can raise your hand. We'll unmute.
Okay, I think I would assume, Mr. Param and Ms. Sapta, that people are completely clear on what you have taken.
One
Hit
more
at the
question
first
has
go, I
come,
think.
Param, that can we add metadata separately? One question has come from Gautam Yam.
Yes, when we say metadata, adding it separately, yeah, it will be part of the same metadata JSON file, but it can be a separate section. It's since a JSON file, it can be a sub attribute in the same file. So that can be possible. That is possible through this particular toolkit. Yeah. So whatever the metadata we want to add, that will be part of the same JSON file, but it could be a sub object or sub dictionary in that same JSON file.
Okay, so how to prepare a data for RAG with LLM? One question has come from Krishna.
How to prepare? Okay, so it's it's not based on the task as such, in the sense we can use this data prep kit for any specific task, since only this data prep kit puts some restriction on the attributes which are needs to be present in the Parquet files. But as long as the input data follows that specific structure, for any use case, this data prep kit can be used, right? Yeah. Sapta, do you want to add anything on this particular question?
Yeah, I mean, yeah, you can even download some of the data sets which is readily available in the open sources like Hugging Face, and Data Prep Kit provides many modules which can help you with ingesting those data and start the processing. We have multiple modalities we support, right? You can even download code from a GitHub repository and use ingest to Parquet transform, which is yet another transform in this repository, and you can directly convert the zip files to Parquet files and just start with your transformations. I hope that helps.
So there's a question on what are some ethical considerations surrounding the use of LLMs?
I'm not the right person. Hima is there?
Is Hima there? Yeah, she's there. Robin, you have to co-host her.
1 second. See. Can you spell that name?
H-I-M-A,
HIMA.
Okay, 1 second. Yes, ma'am, you can unmute.
Hema?
Yes, thank you.
Yeah.
I was able to unmute.
I'm sorry, we didn't identify you. You were there in the session. Welcome to the session, by the way.
No problem. No problem. So I missed the question. Can someone repeat the question again, please?
Ethical considerations in the usage of LLMs.
Okay, yeah, that's a great question. Also, a very interesting question. So, one is since we all of the sessions have been on data, I will wear that lens to answer this question, right? When we think about ethical considerations of what data are we using to feed the LLMs, we need to some considerations to keep in mind is that maybe the data is available on the internet, but does it have the right licenses? Or if we talk very specifically about GitHub repositories, right? There is a license value associated with each GitHub repository. And sometimes, even though people put their code in the public, the license really determines of how they want others their code to be used, right? Like, for example, some GitHub repositories have a very friendly license like Apache 2.0, right, which has no strings attached, and that means that data can be used for commercial, academic, any purposes. But there could also be restrictive licenses. So I think that is one very important consideration, that when we are thinking about building LLMs, be it pre-training LLMs or fine-tuning LLMs, what data are you adding? And is that data ready? Is that data actually okay to be used? That is, I think, one big concern that one should keep in mind while thinking about LLMs. Another angle is around ethics for LLMs is, are we adding or are we making sure that we remove the personally identifiable information from the data? For example, sometimes the data could have names or email addresses or anything that helps identify a unique person. Those are the things that you want to remove before you show the data to the LLMs. So this is, I think, right, really, I think, wearing the data lens. And these are some ethical concerns that one should keep in mind while trying to train LLMs or fine-tune LLMs.
Thank you, Hema. Vignesh T, I think I hope this should have answered your question. If there are any follow-on questions, please write back to PALS and we'll get it answered. Robin, with your permission, before you hand it over to the CNC for the concluding remarks, I would have an important information to share. CNC,
Yes,
can I
ma'am,
do
go
that for
ahead.
2 minutes?
Yeah, sure.
Thanks. So, students, I would like to share. Just give me a second. Yeah. Now that we have asked few questions, we did not ask, so I'm assuming that we are all very clear with the 3 sessions that we have taken. We took one on 27th, 29th, and today was the last and final session. And we are going to have a final quiz. Now, all of you will be definitely asking me for certificates. Please make sure that this is one step required, mandatory, apart from attending all the 3 sessions to get your certificate. So you're only one step short. So don't miss this particular step. I would like to just go over this quickly. If there are any questions, we will take it post all the speakers have left the session. We won't occupy, but I'm just using this because many of you are dropping out of the session and I don't want to miss all of you. So what we will do is, along with the feedback link, today we will be sharing the quiz link. It will be a Google link. Now, when you click on this link, it will say it is not open for response. So don't panic. We will not keep it open today. This particular quiz will be open only on 2 slots on Monday. Sorry, I didn't write the date. Monday is basically, I think it's September 2nd, if I'm right. So September 2nd, Monday, it will be open in 2 slots. One slot will be between 11 a.m. to 11:30 a.m. and the other slot will be 6:30 p.m. to 7 p.m. So to make it convenient for whichever slots for you, we have kept it we'll keep it open in 2 slots. Now, what will happen is, during this time, when you open at 11 a.m., click on that link, the quiz link will be open. But if you open at 10:55 a.m., it will be closed. If you open at 11:35 a.m., again, it will be closed. So the quiz link will be open between only in this slot that has been given. So during this slot, what we will do is, the PALS PMO office will also be available in the same Zoom meeting as how all the 3 sessions were conducted in the same session, very session that we are today. We will be available. You don't need to log in into Zoom at all. You just have to click on the quiz link, take your quiz, answer your questions, and then, close the question, submit the response. But in case you have a doubt, you don't have the Google link, you have some questions, of course, we're not going to help you with answers from the questions, but with whatever other things for the administrative side you have, you can log in into the Zoom, ask your questions, and then log off. We will be available. It is more like a help desk that will be open for you during that half an hour slot. Now, this quiz will be a 30-minute quiz with over 60 questions. So 20 seconds for each questions. So you'll have to quickly answer them and close the session. So as many questions as you have taken. Now, this is a very mandatory step for us to finally conclude that you have understood whatever we have taught in the last 3 sessions. So I hope the instructions are clear. I will keep the screen for 5 seconds. Take a screen snapshot and save it with you. Thank you.
Thank you, Mr. Jata. Now I request Mr. CNC to give a concluding remarks and vote.
Thank you, Sujata and Robin. I know I'm standing between lunch and all the participants. I'll make it pretty quick. Yeah, I think you'll all appreciate the topic chosen for this lecture series. Is a very important one in this digital era, where the LLMs are going to play a significant role in the future. And starting with introduction to LLMs with a focus on data, algorithm, Hema, and Selja took the first day session, and there was interesting participation, and a large number of people joined. And the second day, Shivdeep and Anshul, introduced the data toolkit with all the components like, the Granite is the basic tool. They talked about Parquet and all of that. And today, Param and Sapta joined, and they talked about the Vulture and, the other things. So what is the other one? Vulture and one more piece, Vulture and Panda. And they walked us through the detailed session on how to use all of this. And one important thing that we learned is dead code removal is very important in some of the large projects, with multiple versions, a large project extending over a year or two, where, it's different people, get involved in the code and specs keep changing. And that's, the good amount of dead code remains, and it brings about a lot of inefficiency in the overall application. In terms of occupying memory, in terms of processing, using CPU time. Not only that, teams like testing team and all will start writing test scripts for such a unusable or unreachable code. It's so much of a waste of time. And we used to have code audit team going through all the code, with a big comb to remove all the dead code. And it's very interesting to see that in this particular tool, there's an option for checking the dead code and removing it. I think it's a very nice thing that I learned today. And I think there's a lot of takeaways for students, and very interesting questions from students came. Very nice to know that they all got involved in this series. I must thank IBM Research Lab, scientists, who are doing leading edge work, who took time all of this last 1 week to share what's going on in the IRL with respect to the current thing. We have take a moment to thank Hima, Shailja, Shivdeep, Anchal, and today Param and Sapta, and Kamal, who put together a team for us to benefit. Thank you all so much, and thanks to faculty and students who stayed through all these sessions to take away a big thing for their future career and learning as well. Thank you very much, and hope you are able to put to use. And any questions, Sujata said, you can always come back. And we'll have this recording of all the three sessions shared with you all, so you'll be able to go through at leisure. In case something is not clear, you can play back and understand as well. Nice weekend. Back to you, Robin.
Thank you, Mr. CNC, a team of IBM. Thank you, Ms. Sujata. Okay.
Thank you.
Okay, so I'll stop the recording and stop the streaming also.
Any remark from Param or Sapta? Any remark from your side?
Yes.
You're free to give a 1 minute or 2 minute remark as you please.
Please.
So, do you want to go ahead?
Yeah, thank you. Thank you for this opportunity. It was really great to present what we were doing in the research labs and present it to the students. And we're looking forward for good contributions from them into the data prep kit. Thank you.
Thank you.
Yeah, thank you all. If you have any doubts or something, you can directly post your questions to the repo also. And if you have some suggestion with respect to improvement of that tool or any, you can directly make any contributions. It's a very live project. You can post your questions. You can make code contribution. Yeah, this will give some idea to the open source contribution. Yeah. Thanks,
Thank you.
So just for our statistics and knowledge, Mr. Param and Sapta, would you be able to tell if there are multiple people who have logged in and did a hands-on thing with you today? Was there any statistics that you have?
It's difficult in the sense, so only we can make out from the repo cloning perspective, but as such, we cannot, in the sense whether they only when if they are able to raise a PR kind of thing. For example, if they have made some code changes on their local system, they are free to kind of raise a PR kind of thing if they feel that if the code is complete and they want to kind of do a contribution. Yeah.
Okay. Because yesterday I think Shivdeep was like telling that multiple people have logged in and it's probably slowed down the system. That
Okay,
the
that is
hugging.
yeah, true.
I don't know. I really don't know if I'm saying the right word, but then that's what he mentioned. So I was a little happy thinking that yes, there are people who have done the hands-on session along with him. So I wanted to gauge today's thing also.
Yeah, okay. So basically, since we have not downloaded the data, so Hugging Face, in the last session, we downloaded the data from Hugging Face, and it was like a good volume of data. So the data traffic will be much higher compared to today. Yeah. So today we just downloaded 2 or 3 files, some few bytes. Yeah.
Yeah, we also had a notebook hosted in Google Colab. Maybe that also helped to track, the activity.
So today we had 14 people, I think, who forked the repo along when the session was going on. So I'm hoping that they were able to at least follow. But I also hope that maybe more students, once I think the videos are posted, they will be able to look at the video and follow it step by step. So if we see more forks from students, on the repo, we can definitely communicate it back to you.
Sure. So 14 is the number that I heard it.
That's right.
Yeah. Okay. Thank you. Thank you, Hima.
Thank you all. Bye.
We started off the session and we ended with Sapta and Param today. So thank you so much for all of you.
Okay. Bye.
Absolutely. Thank you so much for the opportunity. Goodbye.
Take care. Bye. So participants, there are questions on